Hey everyone, this week I'm going to be talking about my FLL robot designs over the years. A few of my viewers have requested to see the various FLL robot designs that my team used through the different years that I've competed in FLL. Obviously everyone's seen Sirius because that's been on my channel a lot, but some people want to see the previous designs that I've used in competition. So that's what I'm going to be talking about today. Now, I competed in FLL for 3 years, and that's something I've talked more in depth about in my Q&A video, so I recommend that you go see that if you haven't seen that already. But today I'm going to be focusing on the robots that I've built. Something else I discussed in my Q&A video is that when I was in FLL, I was primarily a builder, and I was mainly responsible for building the main chassis that we used for each of the robots. So the chassis that I'm showing you today are primarily my work, and then my teammates would later modify that with different attachments. Alright, so the first robot that I designed in my 6th grade year, my first year of FLL, I actually have nothing to show you of that because I don't think that I have any pictures or videos or LDD, which is not a crisis because it was a very unremarkable robot anyway. I think I primarily just used whatever building instructions came with the specific set that we had. So it used the large white motorcycle wheels, and it was just more or less copied from the building instructions. But hey, everyone has to start somewhere. Even me, I mean, a lot of people think I'm some kind of building wizard, but I had to start somewhere. And my first robots weren't the greatest, and you just learn from starting out, you learn from your mistakes, and you learn from what's already out there. In my case, I learned from the building instructions. So yeah, I know that's kind of underwhelming, but I don't really have anything to show you for that one. The next ones are more exciting, I promise. My second year of FLL is where I had my first noteworthy robot, and lucky for me, I actually made an LDD for this robot back in the day. So the first thing you should notice is that it's an NXT, because this was the Senior Solutions year, and this was before the EV3 was even released, because the EV3 was allowed in competition the year following this one. The next thing you should notice is the motors are situated upright in the most conventional position, as opposed to Sirius, which actually has the motors inverted. And that's before I started this practice of inverting the motors to save space. But I still use the tall motorcycle wheels, and this is something that I've used on all of my FLL robots, is these tall thin motorcycle wheels, because they're fast and space efficient. In the back, this third wheel, rather, not really a wheel, it's more like a roller on an axle, and this allowed the robot to, of course, drive forward and backwards, but also slide when it went to turn. And this would avoid getting caught on any edges or seams in the wooden mat. The NXT brick is actually mounted forward. That's also before I discovered the advantage of having the brick backwards. On the front here, this entire contraption is actually an attachment, which I'll get to in just a second. You see on the bottom front here, there are two sensors. There was a light sensor, which we used for line following, and a color sensor, which we used to detect the colored patch at the end of the line to stop. Right here, this rod is actually kind of like I almost want to say a ratcheting mechanism, but I don't know if that's the correct word for it, where if the robot was driving forward, it would push against a lever, and it would push the lever because it would lock in this direction, but it would be able to swing in when the robot went reverse. And like the point of that was for one mission, I think it was the exercise wheel, where the robot would drive up and spin the wheel, but then reverse and go back to base. The main base of this robot, like the core robot, is really just these two drive motors, and at the time I thought this was a very compact design. Of course, since then I've made much better, more compact designs, aka Sirius, but I want to judge this robot for what it is. On the front here, I know I mentioned this before, this is actually an attachment. This is one attachment point and another attachment point's down here, and this motor is included in the attachment. You see the motor actually drives a worm gear, which drives this lever. This front attachment was something that we designed to solve the weightlifting mission, which was some kind of contraption mission model that had a lever on the front, and it had the gearing set up so that it had a lot of resistance, and it was very difficult to lift up this lever. A standard NXT motor on its own wouldn't be able to lift this up, and so I devised a mechanism that used a worm gear to multiply the torque of the motor and eliminate any of the I want to say backlash, but backlash isn't the correct word either. But anyway, the advantage of the worm gear is it multiplied the torque and it allowed the robot to lift up this weightlifting machine pretty easily. And this is one of the signature parts of our robot's mechanical design, and this was one of the contributing factors that led us to win the Long Island Regionals and move on to the World Festival. Before we moved on to the World Festival, we expanded on this mechanism even further, where we added a ramp to the attachment with a pneumatic compressor that was driven by the motor. And what this did is it allowed us to do both the weightlifting and the bowling mission at the same time, where the pneumatic compressor would pump as the weightlifting arm came down, and the tubing on the pneumatics was timed so that as soon as it reached that weightlifting machine, a pneumatic gate would release and let a ball roll down off of the ramp and into the bowling pins. The aim wasn't perfect all the time, but it was a pretty ingenious decision, especially for a bunch of 7th grade kids, and I'm pretty proud of this design. So here we are with my FLL robot design for my third and final year of competition. This was the Nature's Fury year, and this is a very interesting robot. It's still powered by an NXT because at the time this was the first year they allowed EV3s in competition, but my school couldn't afford EV3s, so we're still using NXT. This year there was a lot of mixing between NXT and EV3 teams, but I finally flipped the NXT around to the back to make it easier to access it when you're in base. The other thing you should notice is that this is the first year that I inverted the motors, and this allowed the robot to be much more compact. As you saw with the last robot, there was actually a lot of wasted space beneath the motor and the brick, and I solved this problem by flipping the motor. I still use the tall motorcycle wheels, and in the back I have the third motor, which was fully contained within the base robot, if you will, whereas last year's robot I had just the 2 drive motors that stuck with the robot base, and then you move the third motor around where you needed it. This year the motor would stay. Something special you should notice on this motor in the back and in the front is, that's right, dog gears. That was the first year that I used this, and I was inspired by a Danish team that I saw on YouTube, and they shared their design for dog gears, and I modified their design slightly to suit our needs. So I was able to make use of the front and the rear dog gears, which were powered by this motor. On the front of the robot, there's a pair of light sensors which we used for line squaring, which is the first time I ever did that. And we also had another pair of sensors on the back which would allow for line squaring in reverse. So as you can see, there are a lot of similarities between this robot and Sirius. In a way, I even call this the NXT predecessor to Sirius. And my 8th grade year was the most impactful, and that's when I learned the most about FLL. And that's what you hear me talking about in my videos, is my experience from FLL, especially with this robot. As you can see, a lot of what I teach comes from what I learned building this robot. And on the bottom, there's even a special surprise. There are 2 more dog gears on the bottom, and you may be wondering what those are for, and it's kind of odd. They're powered by each drive motor, where this left dog gear is powered by this left motor, right motor powers this right dog gear, and so there's an axle that powers the wheel, but there's also, it comes out into the middle here, and there's a 90-degree gear connection with those 4-tooth kind of weird knob wheel things that transfer power down here. And this is something I'm especially proud of, because this allowed us to attach this base robot onto another piece of machinery or attachment underneath it. This attachment was something that we nicknamed the Behemoth. We basically built a 4-wheel drive driving base with locked axles and a fixed gear reduction. The purpose of this was to allow the robot to complete one of the Nature's Fury missions, where you had to climb over a series of obstacles, some small walls, and get to an end zone at the end of the FLL match. And so our 4-wheel drive monster truck was the answer, and these dog clutches on the bottom would allow the robot to transfer power from its 2 drive motors to this 4-wheel drive mechanism and allow it to drive around. And this was just something that I think even now is really cool. I mean, I'm sorry if I'm patting myself and my team on the back too much, but this was just such a cool thing that we did, and it was so satisfying to see it work too, because it wasn't very quick, but it would roll over these mission models, and in some cases it would even crush them and pulverize them, which is kind of unfortunate for the referees, but hey, it did its job, and this mission especially scored us a lot of points. It's a shame that I really don't have any videos. This photo is the only one that I have of it, even that's not very good. But it was just a really cool thing to behold, and this is probably one of the designs that I'm most proud of from my 3 FLL years. And by now I know what you're thinking, what about Sirius? So I designed Sirius in February of 2015. That was actually after I aged out of FLL. And the reason why I built it was to be able to show some kind of robot in the tutorial series that I was launching at the time. And my first video, I think, was on line squaring. So that's why it has the 2 sensors in the front, because that was the robot's original purpose. And as you could see, this robot is actually very similar to the robot that I used in my 8th grade year. Of course using an EV3, but a lot of the stuff stays the same. Having this inverted brick on the top, the inverted motors with the tall motorcycle wheels to save space, the dog gears in the front and the back, though no dog gears on the bottom because it wasn't really necessary, and 2 light sensors, in this case EV3 color sensors, on the front. I didn't need the ones on the back. Something that you may find interesting if you haven't heard me say this before is I've never used Sirius in competition because I built it after I aged out of the competition, though some people have, and I don't know exactly that I'm happy about that. I mean, imitation is the highest form of flattery, but I prefer people not copy my designs. Anyway, the purpose of Sirius was not to compete in a competition, but it was to be a model FLL robot that hypothetically could be used in competition, but at the same time demonstrate a lot of the concepts that I wanted to teach in my tutorials. So you have the dog gears in the front and in the back. You had the inverted motors, the tall motorcycle wheels which save space, the sensors in the front for line squaring, and the ball caster in the back. And I've covered each component of Sirius individually in its own tutorial. This design is, I'm patting myself on the back, and I'm sorry for that, but this is, I think, a really solid design. It's extremely compact. If you think about how many motors, so you have 3 motors and 2 sensors in there, and it's so versatile too, allowing you to attach attachments to the front and the back and be able to power them with a motor. So it's a very compact, very dense design, and I have to say it served its purpose very, very well. Its purpose being to demonstrate concepts of tutorials. And to think about it, I'm 17 now, but I designed this when I was 14 years old. So that means almost 3 years later, I'm still using the same robot that I designed when I was in 9th grade for my tutorials now that I'm a senior in high school. So that's something I think is pretty interesting to think about. This is just a very solid design that I used a lot of my experience from FLL to build. And I always wondered what I'd be able to score if I was allowed to still compete in FLL and use this design, but that question will never have an answer. So those are the robots that I've made over the years. Let me know which of the designs you like best, or if you have any comments or questions about any of the robots that I showed today, and leave a comment in the section below if you'd like to know any more information about them. Thanks for checking out my video this week. If you found it helpful, be sure to subscribe to my channel for more tutorials like this every week. And if you have an idea for a tutorial, leave it in the comments section below. Thank you, and I'll see you next time.